So we have done several things with inequalities. This is our last one of graphing inequalities. It's the last section in chapter 3. We're actually going to be dealing with systems of equations. So that means you're going to have 3 equations in one. But we're going to solve them mathematically. So this is the last section in this chapter that we're going to do graphing. And it's kind of, it's a lot of what you've already done. It's just there's only one new part in it. So please make sure that you are doing the previous section. That way this will make a lot more sense. What we're going to be doing is similar to what you did in the last few problems of your last section, when you're graphing 3 lines and they're all connected, and so they're all in an enclosed area, and we found the vertices. So these are the vertices. These are ultimately your solution. This is called bounded. That means the lines are all, the answer is all enclosed, and this is called unbounded. So that means that the 3 lines leave an opening, so that means it can continue on this way. So again, you have bounded and unbounded. Now, each of these have a maximum and a minimum. Okay, so they're going to give you 3 equations, and they're going to give you a 4th equation called, it looks like f of x comma y. That's your equation. You don't actually graph that equation. What you do is you use that to find the maximum and the minimum, and I'll show you how to do that in the problem. So these are the steps that you're going to do. You're going to be writing this into your flipper also. The first step is to graph the system of inequalities. So basically what you've been doing, you're going to turn all the inequalities, the less than, the greater than, all that sort of stuff, into an equal sign, and then you're going to graph it and find where the shade and where it overlays. Then you're going to find the coordinates of the vertices, so you're going to find the coordinates of these, or find the coordinates, so it's either 3 or 2. And then unbounded it's 2, and a bounded it's 3. In a bounded you have a minimum and a maximum. In an unbounded you have one or the other. For this case, this has a minimum, but it doesn't have a maximum, because if you look here, it keeps going. And sometimes it'll turn this way, so that means it doesn't have a minimum, but it completely has a maximum. And then your last step is to take each of your vertices and put it into your final equation. The smallest number is your minimum, and the biggest number is your maximum. So we're going to go through that. So go ahead and write this down. Go ahead and do your vocabulary, and we have one example that we're going to go through, but it's a little lengthy. Alright. So again, they give us these equations. These are the equations we actually are going to graph. Okay? So the first one, we're going to change it into equal sign, x equals 5. Remember, when it has x, that means it's straight up and down. Now these are all greater than, less than or equal to, greater than or equal to. So that means they're all going to be solid lines. So I'm going to look at x equals 5, 1, 2, 3, 4, 5. Ooh, it's not right. Okay? And I'm going to graph 0, 0. Test 0, comma 0, because it's not on 0. So into the original equation. So, because I only have an x, I'm only going to use 0 is less than or equal to 5. And that is true. So that means I'm going to graph everything on this side. Okay? My next one is y equals 4. So I'm going to find 4. 1, 2, 3, 4. And it's a solid line again. Okay, and I'm going to test 0, comma 0. So that means 0 is less than or equal to 4. This is in fact true. So that means anything on the bottom of this line. It includes this side too. But I don't have to actually graph. This is my answer so far. Okay? Finally, we have here x plus y is greater than or equal to 2. So what I'm going to do here is I'm going to do x plus y equals 2. Okay, I'm going to subtract x from both sides. I end up with y equals negative x plus 2. Alright? So because of that, that means I'm going to start at 2, 1, 2. And then this is 1 over 1, negative 1, so I'm going to go down 1, over 1, down 1, over 1, down 1, over 1. Right? So, those are my 3 vertices. This one is 3, 4. It's very important that you do this on graphing paper so that you have the exact numbers. This one is 1, 2, 3, 4, 5, 2, 3. Okay? And this one is 1, 2, 3, 4, 5, 2, 3, 4. Right? So, so my answer is where they all 3 overlap, which is this triangle right here. So this is bounded. That means it's all in together, unlike it's unbounded. So go ahead and write this down. Okay? I'm going to erase so that you can see how to find the maximum and the minimum. Let's find the maximum and minimum right here. Okay? So our answer is right there. This is how we're going to find max and min. Okay? What I'm going to do is I'm going to have my vertices, my x comma y, and I'm going to plug it into this equation. 3x minus 2y, that's what this equation is for, to find my maximum and minimum only. And then whatever my answer is, okay, that's the smallest number is my maximum, and the biggest number is my maximum, smallest number is my minimum. So the first, I have 3, 4, 5, 4, and 5, 3. So I'm going to go 3, this is my x, the first number is my x, 3 times 3 minus 2 times 4. So 3 times 3 is 9, minus 2 times 4 is 8, so 9 minus 8 is 1. So 3 times 5, which is 15, minus 2 times 4, which is 8. So 15 minus 8, 7. Sorry, I had to use my fingers. And then finally is 3 times 5 minus 2 times 3, so it's 15 minus 6, which is 9. Okay? So this right here is my smallest number. So it's my minimum. And this is my biggest number, so this is my max. So my minimum is 1, and my maximum is 9. Now it's a pretty lengthy problem, of course, but it's all of this shading stuff is nothing too new. This is probably the newest part right here. So after you shade and find an overlap, you find the vertices and you plug it into that fourth equation, which is something you haven't had previously. Once that fourth equation, once you're done graphing these 3 equations, that fourth equation is just used to find my minimum and maximum. And minimum is the smallest number, maximum is the biggest number. So go ahead and try it. Page 141, number 2. Page 141, number 2. Write this down. Don't forget your vocabulary, and I'll see you in class.